So today I welcome you all to episode 7 of TechCast. For those of you who don't know, TechCast is an event series brought to you by Open Source, a community where we invite guest speakers to share their insight and expertise with us. So today our guest speaker is Hariket Sheth, an SD intern at Associate General and previously an MLH fellow. So, about our guest speaker, Hariket Sheth is a final year BTech Computer Science Engineering student at VIT Chennai with a remarkable track record in software development. And his passion for learning, coupled with having hands on experience and a strong academic foundation, has led to a notable achievement and contribution in various domains. So, um, so thank you for joining us, Hariket. We are excited to have you with us today. Please take over and start the session.
Yeah, thank you, Shubham, for the um introduction. I hope I'm audible and visible too, right?
Yes, yes, you are.
Yeah. So I'll be taking you towards this topic of CI/CD today, and I'll also try to explain about the various security risks which we face in this domain. And if you have any doubts or if you need any more explanation in that, you can actually post your comments or anything, and you can ask out freely whenever possible. So yeah, I'll just share the screen. I hope the window is getting shared.
Yeah, we can see it, Hariket.
Yeah. So this is the topic for today, which we'll be covering, that is securing the CI/CD pipelines. So yeah, I'll just take you forward to it. So how many times, have you actually encountered a situation where you got locked out of your home? Like you just forgot your keys and the door got locked. Similarly, suppose say you were sending a message to somebody and you by mistakenly send it to someone else. Maybe you're sending it to your girlfriend and you send it to your mom, something like that. Or suppose say, let's imagine a situation where you were supposed to push a code to some repository. Instead of pushing that code, you by mistakenly deleted some files while making a commit. So these are some scenarios which can happen and which should not be you can say should be monitored specifically before it's actually executed. So this is what we would be also discussing here in CI/CD pipelines too, because when you will start your career as an intern or maybe as a developer in some months or maybe in some years specifically, so you have to take care of such things because these things are not tolerated in certain organizations. So suppose say if I talk about my organization, which is a financial based organization, even not a financial organization, you might have certain guidelines or security things that might be there. If you don't follow to those guidelines or anything, you might actually lose your job very quickly in your career. So these are some important practices that you should also keep in mind. Moving forward with who am I? So basically, Shubham already gave an introduction. So I am basically an active open source contributor, and I have worked with certain companies like Samsung, MLH, and GitHub as a software developer before. And right now, I'm interning with Society General as a developer. And you can find my profile in this link, which will be circulated to you later if you want to connect with me also. So this is what the agenda would be looking like for today. So we'll discuss what is CI/CD and why we require CI/CD, the pipeline procedure, the life cycle and the risk which are there in the CI/CD process, and then we can have your question answers at the end. So we have been talking about this quite a lot, that CI/CD from the start. So we need to explain, we need to understand what exactly this process is. So when I say CI/CD, the CI stands for continuous integration and CD stands for continuous deployment. So that's what we are kind of focusing here on. So when I say CI, the specific short terms which I have like kind of laid down here is pushing the code to VCS. VCS actually stands for version control system. So you might be using GitHub. So those are kind of version control system where you make a commit and there's a history stored for it. Basically, even a small space, a small line, whatever changes you make is recorded as a commit. as a history. So those version control system, if you push your code to such kind of a system, we kind of count it under the continuous integration part. And when you build server checks, or when you kind of push your code, it's stored or it's get pushed into a GitHub repository. As you know, you might be using GitHub for your college projects or some J components in VIT. So similarly, when you push your code to a company's repository, something like that, there are certain checks which they have written, certain test cases which are written, which are executed so as to check whether you have actually what you can say uh, made and like ensured that all the compliance requirements are actually fulfilled or not. So those are some of the checks which are done before it's being actually integrated. And then you get a feedback also whether it's passed or failed based on the number of tests you have. So suppose say you have 10 test cases and 9 of them pass, you get a feedback that 9 have passed and 1 have failed. And for the last part is code gets packed and stored in repository if all of the test cases are passed or something like that. So this is the continuous integration process. And the CD process, which is deployment process, is how you can release this code to your website or URL. So suppose say you have a project or you have a product in a company and it has a public URL. Suppose say something like product one dot com or something like that. So how do you deploy it continuously once your changes are pushed? So CD pipeline helps you for that. So when you push your code automatically, it will take the code, the new code, and it will deploy it, and it will reflect it on the domain or whatever you are using for that. So if you use a CD kind of an approach, deployments are quick and often because you don't need to manually do it. When you have to manually do it, you have to take the code, you have to check where it has to be placed, you have to update the endpoints, everything. So that is a very tedious task to do if you are doing it manually. And if I talk about a very professional perspective, in companies, it is not possible for you to do it manually every day. So that's why having continuous process is actually helpful for that. And CD, as I already expressed, helps in automated deployment. So that's what CI/CD basically looks like. So now the question comes, why CI/CD? Is because when you have like code changes, like suppose you're making a small line of fix or small kind of hot fix, which we call it in companies, where something is actually not working and you are adding a code such that the issue is fixed. For such kind of small code changes, you don't actually feel the need to deploy it automatically, right? Like suppose say you are just adding one line of code and you have to manually deploy it. That's a huge task. Like if you manually deploy it, it might take you 20 to 25 minutes to deploy it perfectly. So you can't spend 20 to 25 minutes of your time just for a small code change which is of one line. So that's why if you have a CD pipeline, it will run in background and it will do the deployment process for you without you having to spend 20 to 25 minutes. Because when you enter a corporate world, even such kind of time is important for you and you don't want to waste it. Continuous testing is the another point. So you make errors. Okay, it's very normal to make errors. Even if I am experienced, even I have worked with so many companies, even today if I write code, it's possible that I miss out on semicolons, I miss out on some syntax, I make some errors. It's very much possible. So it's not possible that when you push your code to a repository and you are having a review, the another person, sometimes it's not possible for him also to you can say detect the errors which you have made. Okay, so if you have continuous testing, if you have some tests written automatically, or if you have some generated test cases already in your repository, it's very much good that whenever you push your code, it's automatically checking all those test cases and gives you a report. Because manual review is okay. Manual review is one of the part of the process, but if you have automatic testing already there, it will check all the syntax error, all the security risks and all that, which will help you to have a better code version of yourself. And early fault detections is also one thing which comes as a part of continuous testing only. You have faster release rates also. So when you can say that in today's world there's a lot of competition. So if I say about messaging apps, you have so many messaging apps today. You have Meta Messenger, you have WhatsApp, you have Telegram, all that. So many applications are there, and so many startups are also like kind of working towards some same problem statement. So much of competition is there in the market with AI, ML. So you need faster process in your company, corporate as well, because it cannot be like that you are working on a feature and it's ready, but it takes 5 days for you to deploy it on your product or actually deliver it to your customers. So it should not be that kind of a case. Is my slide freezed or something? Really
Okay, it was kind of freeze. Now it's CICD.
Okay.
It's on it.
Okay. Yeah. 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 Which slide are you able to see? Like the YCICD or some other thing?
Yeah, earlier we were able to just see the first slide. Right now it's YCICD.
Okay. Yeah. Sorry. I think some technical glitch over there. So, yeah. I was in, yeah, faster release rate. So yeah, whenever you have a CI/CD pipeline, as you see in the diagram as well. So when you commit the code, it builds your code. Building is basically like running all the test cases and all that. So in building, you have unit test cases, integration test, and all that, which comes under CI process, the continuous integration, which I was talking before. So this three processes comes under CI pipeline. So when you actually push your code or commit your code to any repository, this CI pipeline is the first thing which get executed, and then comes the CD, which is the continuous deployment part, where you have the review. It can be a manual review or it can be something like a automated review, which we discussed before, and then you have staging where, and then it goes to the production. So you might not be knowing this very early in your career, but there are certain environments in corporate or when you step out in a development career. So they have developing environment, they have testing environment, which we call as UAT also, the user acceptance testing, and the third environment is the production. So whatever version of the thing which you are seeing right now, suppose if I'm talking about WhatsApp also, WhatsApp or Messenger, so the one version which you're using right now is coming from the production environment because that's what is made available for the public. The other two environments are for the developers to actually test out their features or maybe do some testing, do some experiments or something like that. So those are kind of the environment. So when you come to CD pipeline, it helps you to deploy your changes to the production environment so that it's delivered to the end user directly. So, and also why CI/CD, you have smaller backlog because suppose say today I'm making one change and I have to deploy it by the evening. I deployed it by the evening, but I got to know that I like some other developers from my team also made some changes which were not included. So this makes a backlog. Okay, now tomorrow you will go, you will deploy those changes, but again you got to know that some other developers have made some changes. So this whole process would continue, and you have a lot of backlog, and you have lot of, you can say, inconsistency in the version of the deployment. So this should not happen. So if you have a CI/CD pipeline already in your projects, or if you have it in your process, then it helps you to push as and when you like kind of commit the code or as and when you deliver the features. It helps you to do then and there whatever changes there. It will reflect then and there. It also promotes customer satisfaction also because you will not have to wait for this thing to reflect on your actual links or something. Because as I said, if you do it manually, you have to update each and every endpoints yourself. But if it's a continuous process, it will update everything, even for the customer. Within 2 minutes or 1 minute, he'll be able to see it on his screen also, the changes which you have made and early maintenance and updates. So yeah, you don't have to spend much time on maintenance. Updates are very quick if you are using GitHub Actions specifically, or popularly you might also come to know about Jenkins, which is also a popular tool used for CI/CD. So updates and anything like maintenance work is very easy in such tools. You don't have to spend anything on that. It generally is done automatically, or sometimes even if it's manual, it hardly takes 5 seconds or 30 seconds for you to do it. So that's what the benefit of CI/CD is. And yeah, this is the pipeline which was also there on the previous screen. So you can say build and the running unit test cases, the running integration test are all coming under CI pipeline, and it comes from your GitHub repository, Git repository, which is there on the local machine. So Git repository, when you push your code to a actual remote repository or in GitHub. All these processes are done in background, which you might not be seeing on your screen or terminals, and it is pushed to artifact repository. And then you have the CD pipeline. So you might have this doubt of what is artifact repository. So when you are working in a company or when you are working in a corporate, there is certain artifact repository from where the packages or your libraries are taken from. So if you're a Python developer, if you are a React or some kind of Node developer, you know that you might be importing certain packages. You have this package.json file. So sometimes you might be requiring certain customized package. So you might be writing npm install for that package, and you will be using it in your project. But when you push your code in the companies, it will check from the artifact repository whether that package is allowed or not, because you cannot just randomly select any package available on the internet and use it in your projects. You can only use the the libraries which are you can say green, which are like green signaled by the company. So artifact repository has all the list of packages, libraries which are like okay to use, which are secure, and which are actually having a stable version of it, not a beta version of it, or one which is in testing. So it will just point to the artifact repository. It will fetch the list of all the allowed packages and all that. If it's not there, your code will not be actually going to the repository. It will not be pushed. You will see a failed message in the terminal itself when you are pushing from VS Code or any of your IDEs. And then if everything is fine, if it's everything is present in the artifact repository, then it will be gone for the CD pipeline, which is like deploying to the testing environment, which I discussed, UAT. You have certain acceptance testing over there. Then it will be deployed to staging, which is like the step of deploying. And then you have your end-to-end test, your performance test, stress test also. So how much load your website can take, all those things happen. And finally, if everything is fine, then only it goes to production. So that's a huge process, and it all of this happens in the background if you have a CI/CD pipeline. Then we'll discuss about the risk and all that. But before that, if you have any questions, you can ask. Shubham, if you have any specific question to ask before I cover the risk on CI/CD.
Okay, so why securing CI/CD pipeline is important for any software development cycles?
Yeah. So securing CI/CD pipelines is very much essential for any of the corporate, or not corporate, but any software development company, is because if you don't secure it, there are potential attacks that can happen also. So there you might be hearing about man in the middle attack. You might have heard about DDoS and another like attacks which people can do so that your performance goes down or your application is hacked by the hacker or something. So it should not happen. And CI/CD is, when I say about CI/CD, there are a lot of security risk also that come in this. It's not a foolproof mechanism. You have to actually, you can say, configure it in a way that attackers don't have any loopholes in that. So there are certain points which are there when you say about this thing. So I'll just take it from my perspective over here. When I joined this company, Society General, I joined as an intern. So there's no record of me added to the HR department or any of the repositories. I have to acquire a new access to the company. So right now, when I try to push any code to the repository or anything, I have an unauthorized access, right? So similarly, a hacker, which is like outside the organization, even he has the same access as me, like unauthorized access. So your pipeline should not be kind of be you can say it should not be like something allowing an unauthorized user to perform any actions on them. So if I'm talking about GitHub Actions also, you have to add only specific users to allow changes in that file or change in the configuration. It should not allow any random user to actually access your pipeline or access your personal access tokens, your modification of the code. It should not be allowed. So proper access control should be there. Even if you are talking about interns, full-time employees, both should be there. then you should protect sensitive information. So it's generally seen that in companies, people use certain variables to store their passwords or something. Generally, it's stored in environment files, environment variable secret files, but sometimes, like because of some hurry or some kind of you can say maybe some deadlines are there, so they just hard code their credentials in the CI/CD pipeline itself. So it should not be the case, because whatever CI/CD does is public, like the logs. I'll show you also, the logs are public. So if you are hard coding your credentials, it will come in the log. And after you leave the company, suppose you leave the company, some random guy comes, he'll be actually able to access those logs, and he'll be actually seeing those passwords, everything. So it should not happen. And the third point is like code integrity is also one of the things. So securing CI/CD is important, because if you don't secure it, the integrity of the code would be breached. So suppose say you are not handling the branch rules specifically, so you have lot of branches in your GitHub repository, you are not adding rules in your CI/CD pipeline to take codes from all the branches. If you don't do that, what will happen is you will have partial codes. Like suppose that 12 developers have contributed their codes, but you were able to only take code for the from the 5 developers contributions only. So this should not happen, because it will breach the code integrity. And whenever the CD process happens, the deployment process happens, you'll see the website will go down, because if insufficient code is there, then obviously there might be errors. Or you will see that some features are not available at all in the website link. So that will also lead to your clients complaining about the same, or you might have certain other things also. Also your malware injection. So as I said, that some people do hard code their this thing like credentials. So malware injection is very much possible over there, so it should not be happening over there. If you are using certain SQL queries, if you are using certain database queries, it should not be like publicly exposed over there, because if you do such kind of a thing, injection attacks, XML attacks, all of those things are very much possible in CI/CD pipeline. So securing those via hashing techniques or other things, can it should be there, should be done over there. So that's all about like why should we secure the things. We'll discuss about the risk in detail, so that you get to know what all risks are possible in this also. So first risk which I have written over here is insufficient insufficient flow control mechanisms. So when I say about that, insufficient flow control mechanisms refers to ability of,
Hariket,
yeah.
I guess the screen is again free or frozen. We can like just check it.
Okay, yeah. One
Ah, now it's fine.
Okay. Okay. So yeah, insufficient flow control mechanisms is what I was discussing. Yeah. So when we talk about this thing, one second. Uh, yeah. One second, my cursor. Yeah. So yeah, in insufficient flow control mechanisms, attacker is basically able to push the code directly to the master or any of your pipeline branches as well. So as I was talking about my perspective as an intern, I should not be allowed to push code to the main branch directly, because I, as an intern, even though I have work experience, but I can make mistakes. So I should not be allowed to directly push to the main code. There should be certain, you can say, a technical lead or my manager who should approve my code before it's actually being pushed to the repository. So certain flow control mechanisms should be there, so that you can say any attacker or any public person is not able to infect my CI/CD process in this. So how can I explain this thing? So CI/CD, as I said, is designed for speed. Okay, so when the new code comes or it comes from a developer machine, it goes to production in minutes, as I said. So there should be also certain review process in between, like a manual review process. Review in the sense approval process. Like I push the code, and before the CI/CD process has started, there should be a review or a approval that I require from a senior developer or my technical lead or the manager. If it's not done, the CI/CD process should not start anyhow, even in background or even automatically. It should not start anyhow. So you should track your CI/CD process in such a way that once the approval is granted, then only your CI/CD is actually started. Otherwise, malicious code or anything can happen in single minute, and your whole application will be deleted. Your repository can be deleted. Everything can be like done if it's not like the insufficient flow control mechanisms are there. So, yeah, what impact can it do on your organization or your repositories is first your repository branch. It can be automatically deployed. The malicious code is visible to the client, or some kind of extortions can be done. Like the company can be asked for an amount to unlock the website or anything like that. There can be a abuse, and auto merge rule can be applied in your CI such that it's not taking code from your repository but from a hacker's repository. So that can also be done if you don't have branch protection rules, which we'll discuss in GitHub. Your whole branch can be deleted in one go, in one button itself. Or fourth thing, what can it done is you can push a repository directly to the artifact repository, which I was talking about. So suppose say how can it happen is you connect it to your hackers repository in your CI workflow file. If you are mentioning your repository name, the hacker will change it to his repository name, and then it will start pushing the packages to the artifact repository from that particular workflows or anything. So it will infect your artifact repository. Your company won't be checking any verifications or anything. It will pick up artifacts from public this thing domain, and the whole code will be actually gone, basically, if I say it in simple terms. So this should not be happening, and so you have to secure those things. If you are using AWS cloud functionality, so you have to check for Lambda functions. You have to check whether you are not directly changing any application code or infrastructure. So these kind of things could be there. How to actually not let it happen is you can configure your branch protection rules in GitHub, or any version controls you're using, such as Bitbucket or GitLab. Such kind of things are there. In everything, you have branch protection rules, kind of a thing. So you can actually monitor them. You can put contributors. So as I said, as an intern, I should be added as a contributor to the repository. Unless otherwise, I should not be able to push the code. The third thing is you can actually monitor your logs, and you can see whether there are any hard-coded credentials or anything. You can remove those things. You can connect your artifact repository via a certain mechanism, not directly, so that hackers cannot change it directly in the workflow file. There's something which is called as pre-approved CI service account, which you can make in GitHub already, and from there you can actually connect your artifact repository so that the hacker cannot access your artifact repository at all from his end. So that's one of the risks. And if I go on to another thing, which is about inadequate identity and access management, this is what I had already covered. It's basically like about broken authentication authorization or overly permissive shared identities. So stale accounts. So suppose say some person in the organization is leaving the company, and you forgot to remove the access from his account. So even though he has left the company, you are giving access to the repository. So when you have CI/CD process in this, you should be taking the user's file also from your this thing. So if certain user has left your company, it should be your responsibility to remove access from him completely. This depends from organization to organization. So in my organization, it is taking automatically the list of employees, and if you are not there in the list of that employees, your account will be terminated automatically. But in certain organizations, this is not the case. So you have to manually remove the GitHub account from that permissible list of accounts. If it's not done, then that user might be doing analysis. That user might be actually pushing codes, leaking credentials, because he was a part of the organization before. So this should not be happening. You should be taking care of identity and access management on priority for that. And the best way to do that is like, as I said before also, that you can manually remove permissions, or you can have a automatic process for that. And another recommendation which is there is like don't give overly permissive permissions. So as an intern, I should only have read permissions, or even if I write permissions to any repository, it should be permissible or it should be limited to certain branches. Suppose a testing branch or a developing branch. I should not have any write permissions on the main branch, because as an intern, like I don't have much experience in the company. I should not be given that much overly permissive permissions. So that is one thing which you should take care when you are actually uh, if you have any plans of starting any startup or something, you should take care as a manager or something like that, that you don't do such kind of mistakes. Then when we come to dependency chain abuse here, typo squatting, package with the same name gaining access to maintainers accounts, such things are there which comes under dependency chain abuse. So a very good example of this is when I say about typo squatting. It means that you make a typo when you are actually importing your packages. So you might have heard about NumPy package. You might have heard about Pandas package in Python, which are like the most famous packages to be used over there. So suppose say instead of writing pip install NumPy, you write something like nsmpy, like a typo, which might is very much possible for you to do. So what it will do, like it will just install the package and it will run the malicious code which is there in the package, which is actually made by an hacker. So this should not happen. And I'll show you if one second. I'll just show you the pip gallery also for that. So this is the pip library. If you are working on Python, you might be knowing that this is the website where you will be finding all the repository, all the packages, libraries, and all that. If I write pandas over here, you can see that all the pandas library versions are listed over here. So all of these are not official packages of pandas actually. Some are not even existing, some are actually made by hackers over here. So you might be having this in your mind that okay, let me install the latest version of pandas, which is 3.0.0.1 as of this website. If you go to this thing, it's possible that this is not the actual pandas library which you are supposed to use. You can see pip install pandas 3 over here. It's generally not the case, because the command for installing pandas is pip install pandas directly, not 3 to anything. So even like suppose say if I type it as this, yeah. So see, if I made a typo in pandas library, I typed as s instead of a here. You can see there's a psndas package. It's a package which is actually, I'm definite that it's made by a hacker for you to make the typo mistake, and you will be just infecting your code like anything. So such kind of things are there. You should be very careful when you're writing your code that there's no typing mistakes or anything. But yeah, as I said, that it's a human mistake that can happen anytime. So it's what I can say. It's not something which you can avoid it at the go. But if such things are there, like typo squatting is possible, you need to have artifact repository, or you need to have checksum verification for that. So as I said, checksum verification is a hashing thing. Like when you are installing a version of the package, all of the companies give you some checksum. So if you go on Python website also, there are certain checksum available. MD5 checksum you would have heard, or other checksums which are there, which verify whether the packages you are trying to pull are the same as what posted by the company itself, like the official package, and not one which are posted by the hackers. If the checksum verification fails, then your package won't be pulled or your package won't be installed perfectly on a system. So you should enable the checksum verification on your code repositories or your CI/CD process, so that you don't land up in such kind of malicious packages. You can other thing which you can do is you can avoid configuring clients to pull latest version of the package. Okay, so in companies you will be finding out that it's not that you have to use the latest version of the package always. You are supposed to use a package which is approved by the company. which is like they would be giving you a range of the versions, and only within that range you should be able to use that package. It's not that, okay, Pandas has released third version of the package, I'll definitely pull that thing and I'll start using it. It should not be the case. You should configure your CI/CD to use a pre-vetted version or a version that you are approving there, and ensure all the private packages are registered under organization scope, which is what we call in short term as artifact repository. Then fourth risk is poison pipeline execution, which we call as PPE. So this happens when an attacker can actually access the source control without access to the build environment. So he may manipulate the build process by injecting malicious code commands into the build pipeline configuration and essentially poisoning the pipeline code, which I'll show you how it is done, and you can ensure that it's not in your case, like it's not done in your projects or stuff. There are three types of it. Like one is direct. It can modify the CI config file directly. So whatever configuration you have done for your continuous integration, that hacker will directly change it, and then you will not have any access to your repository. You will not have any access to what is done in the integration process. All the test cases would be changed. Everything would be kind of taken in from the hacker's repository. Second way is indirect, where your configuration file is present in a separate protected branch, but you don't have direct edit access to it. Okay, so it's the hacker has a read access to your repository. He's cloning your repository, he's forking the repository, he's making the changes in the configuration file, he's adding certain new files, he's pushing it to your repository. You will have a pull request over there, and you are you are having certain deadlines in your mind. You just directly approve the PR without performing any code analysis, and then what happens, the configuration file gets changed automatically, and you have the same hackers this thing attack over there happening in there. And the third one is public, so which is like CI pipeline is publicly available, and without any review, anything or such kind of a thing, CI pipeline is getting infected without like reviewing of the code, which is also one of the things which I'll show you in the demo. Like I have picked up the code QL part for the CI/CD process, which I'll show how that happens. So a recommendation in this, what you should do to avoid this thing is ensure that unreviewed codes are not at all pushed into CI/CD pipelines. Everything, like even a small piece of code of change, should be reviewed by a small, one person or automatically also. You should evaluate the need for triggering pipelines on public repositories. So you should not allow an external person to trigger the pipeline. Okay, it should only a person from the organization or from the developers community to trigger the pipeline. Or if some person from the outside community wants to trigger the pipeline, you should apply a approval process so that he could not directly trigger the pipeline. And the third one is each CI configuration file must be reviewed before the pipeline runs. So when you are approving a PR, before that you should check the configuration, and after approving the PR, you should also check the configuration. If you see any discrepancy, you should stop the workflow then and there, and you should take certain actions over there itself. Then fourth is remove permissions granted on the SCM repository from users who don't need them, which is also one of the things which we covered before. If certain users, if you see in this thing, if you see that they have unnecessary permissions, just remove them then and there, because otherwise it is possible that they'll poison your pipeline execution, and there will be certain attacks. Fifth risk is insufficient pipeline-based access controls. So pipelines have excessively high privileges, which can be abused by an hacker. I'll discuss it in the end slide. In GitHub Action specifically, you have lot of fields, like lot of fields. If you just don't take care about it, hackers are just waiting for you to make this mistake, and they'll just they'll just make an entry to your pipeline, and they'll infect the whole of the code. How to avoid this insufficient PBAC is you don't use any shared node for pipelines, because in companies they are working globally, right? So one thread would be running in India, one thread would be running in Japan, Asia, other countries. So don't use shared pipelines. Don't use any shared nodes for pipelines. And ensure all of your secrets are scoped in a manner that each pipeline or step have access to this thing and all that. Like you can say, is my screen again frozen or something? I'm not sure. One second. One second. Share again. I think it should be visible now. So insufficient PBAC is what I was covering. So you should ensure that secrets are used in CI/CD systems, are scoped in a manner that allows each pipeline and step to have access only to the secrets it requires. Because you might have a lot of secrets in your repository, but you want your pipeline to use only two of them. So only two of them should have access. Rest all secrets should not be used. Then containerize your runners, because you can use tools like Sysbox over there. You might be hearing about Dockers, Kubernetes, and all that. You can configure those also for extra degree of isolation over here. And you can use OIDC tokens, which is complex right now for you to understand. But yeah, this is one of the way to prevent this PBAC attack that can happen. Then yeah, we'll see a demo on CodeQL here. I'll just show you in my one of the repositories. So yeah, before that, I'll just show you one of the things as well. One second. Window. Yeah. So this is one of the test account, GitHub account which I have made. Here I'll show you one of the things. So suppose say this is one of your company repository, okay, and this is the main branch, which is what I called as production, or like this is the place where the main code is taken from. This is what a public version looks like. Then from the main branch, you have develop branch, which is like the branch where the developers push their code. And from develop, you have feature branches, which is like they are working on certain features also. I'll show you in VS Code in form of a graph here. So here you can see the main branch is the whole, you can say the default branch which is there. From there, you have another branch which is called as hotfix. And hotfix is the branch where you make changes. If I explain it better, it's like when you push a code to the production, suppose say something fails, okay, and it's a small fix you have to do. So we use hotfix branch for that, which is like a small change which has to be done to rectify that error. We don't redo whole CI/CD pipeline for that. We go to the hotfix branch, we make the changes, and then it is reflected in the main branch. Then the second main branch is develop, which is your marked in the blue. Develop branch is the where all the developers push their code, and from develop branch only it is pushed to production. And from develop branch, you see that three other branches are coming out, which is the feature branches where the features are being worked on. So as you can see here, one of the branches say delete records, one branches says add mode, the third branch says add navbar. So all of these are derivatives from the develop branch, and these are like worked on by different developers from your team. Once all of these are finished, these are merged in the develop branch. From develop branch, we push it to the main branch, or the version which is available to the public. So that's what the flow looks like in, you can say, corporate world. And yeah, we'll see the demo for this thing, the code QL part as well. I'll just create a new repository for that, which is code QL analysis. So do that. So I'll create a public repository, and I'll be configuring a CI/CD, CI, mostly a CI process over here right now for you to see. So all of these workflows are going inside .github folder. I'll just one second reshare this thing. Yeah. So yeah, in the .github folder, you have to make a folder which is known as workflows, and there you will be writing your YML file, which is yet another markup language. This is the configuration file for your CI/CD pipeline. So I'll just write it as codql.yml. And as I typed, you can say the .yml format. You can see automatically on right side, you can see a menu popped up. This is all the recommended actions or recommended configurations that are available, made available by GitHub for you to add in your repositories. Okay, so suppose say let me focus on this setup Node.js environment. So if you have a React project, if you have a Node.js based project, you can add this specific action or add this specific GitHub action so that it automatically monitors your Node.js project. suppose if you have a Go project, Golang project, then this is one of the things which is made available. If you have a net project .net project, then this is action provided by GitHub automatically here. All of these are pre-provided by GitHub over here, and lot of actions are available. But we are right now configuring the use case for our own analysis part. So yeah, we'll be writing this configuration file for CodeQL specifically for JavaScript based repositories, because that's one of the common workflows which you might understand over here. So yeah, so we'll be starting this configuration file with the name of the workflow, which I'll be giving as CodeQL. And what, like, when you want it to run, like on what specific action. So I want it to run on every push action. Like whenever I push my code to GitHub repository, I want it to run. That's why I'm writing push. And on which push, like on which branches. So as I said, I want it to run only when it's pushed to main branch and not on any other branches. So I mentioned that, and also on other things like pull request. Okay, so not just push, but also when an external user comes to my repository, he opens a pull request on the main branch. I want this action to run on that thing. So I'll mention that point also. Yeah, and this file is indentation, as in you have to take care of the indentation. If you don't do it, it will land up in an error too. So just take care of that. And schedule. So when do I want it to run? So specifically, already I have written that on every push, every pull request, it should run. But this is the code analysis, right? So I want it to run automatically also sometimes, like monitoring it time to time from like suppose say every day I want it to run on certain times. So I want to configure it that way. So what I'll do is I'll write a cron job for that so that it runs automatically over there. So this specific line means like it has a meaning over here, which is kind of, I'm not sure if you'll be knowing, but it's giving me the time. Okay, time in the sense 35 means minutes, 14 means the hours, and the star means actually every this thing, and third is the day. So when I explain it fully, it's telling me that I want to run this job at 2:35 uh, every Wednesday, every 5 minutes on Wednesday. 3 means Wednesday, like as per the number of the weekday, and 14 means the hour. As I said, it's 2 o'clock in 24 hours time, and 35 is the minutes. So I wanted to run at 2:35 every day. Sorry, every Wednesday, every 5 minutes. So that's the schedule I'm specifying on this. You can change it also, but it's just a common convention which I'm following. Then you have jobs. Jobs is basically the steps you want to run it. So I want to analyze the code. I'll name this job as analyze also. It runs on which machine. So I want this to run on Ubuntu machine. So that's why I'll post it over there as Ubuntu latest. Then I'll be writing the strategy. Strategy means what? Like you can say the coding part or the script part. So I'll just fail fast would be false. Fail for fast is basically on first error it should not fail. I want it to perform all the analysis, and then I want this to give me all the list of errors at the end. I don't want it to fail on the first error itself. Matrix is basically on what languages I want it to run on. So I'll specify that thing. When I say code QL as of now in GitHub Action, it supports CPP, C++, C Sharp, Golang, Java, JavaScript, and Python, and TypeScript also. If you are using any other languages, it is not supported right now in GitHub. So you have to see for another workarounds or another mechanisms for that. So now strategy is done. Now I'll write the steps for this thing, like what all steps I wanted to execute. So first of all is name, like sorry, checkout repository. So this is one of the things where hackers are actually very much interested to, you can say, like they are interested to infect your code. If you have a hard coded name over here, like suppose say I'll write my repository name over here hard coded in a hard coded way, he'll just come and change the repository name, and then it will be connected to his repository. So you should never give hard coded repository name here. It should always be automatic, as in this case how I'm not using any repository name here. I'm using this action which is provided by GitHub, which is named as checkout, which will take automatically the repository name, everything from itself. Like when it runs, it will automatically take, so I don't have to do anything over there. Then I'll initialize my code QL, which is like code analysis part. And it will be using which action? It will be using one of the actions from the GitHub library. So I'll be writing GitHub backslash code QL action, and I'll be using the version 3 of this. So I'm just mentioning that. And again, I'll specify with what languages I want to actually do it. So since I already mentioned it on the top, I'll not actually do it here. Like I'll just be taking from this matrix directly. So just it's a this thing, a way of writing the same thing. And then I want to build the code. Okay, once all of this is done, I want to push it to my repository, or you can say I want to see the errors which are there, security breaches which have come. So yeah, build version 3 again. Will be understanding that code QL is necessary, and how to actually write a configuration file yourself as well. Because generally, when you enter any organization, this would already be used. I mean, you don't have to write a configuration file for your organization. But yeah, if some of you are planning to join or start a startup, then this is something which you as a developer have to do as a starting process. So yeah, this is all about the configuration file. Here, there's an error, bad indentation. Yeah, as I said, indentation is necessary. So yeah, inside the steps, all of this will come. So 4 steps will happen over here. Unknown key steps over there. No, we'll just ignore that error over there. Cron job, yeah. So, yeah, checkout repository is like it will direct to our repository. It will point to our repository. Then it will initialize the code QL process, and it will be using the JavaScript language. It will auto build the this thing and auto build the thing, and then it will be performing the analysis part, which is the final part of this thing. So we'll save this thing and we'll see what will be there or what will happen over there. And if I commit my changes over there, uh, you can see the configuration file is applied over there. I can see it in the actions part now. So this is the GitHub actions which we are talking on. So in the actions tab, now I can see my workflow listed out over here, which is named as code QL. And if I open this thing, you can see jobs are running over here. So you can see it like a very long log has come over here. It is just compiling everything. So I just want you to focus on this thing. Like here you can see there's something slash 87 written over here. So there are 87 checks which are all which will be done on your JavaScript code, which you will be posting to this repository before it's actually being pushed. So that's what the benefit of this is. Like I don't have to spend my time to check your code or analyze your code, whether you are breaching any security, any other things. This action would automatically do all these things, and it will say me after 87 checks whether everything is done or not. So now what happened, it gave me a red check mark over here. Why? That's what I like I did on purpose. So what happened over here, if I go on the logs and if I check, it told me a warning that resource not accessible by configuration. Why? Because I did not give this action permissions to write, or you can say perform any analysis on my repository. So that's what you should also check. Okay, so you should not give permissions to all the actions in your GitHub repository. Only give permissions to those actions which require the permissions for that thing. So because this is a code analysis part, I have to give right permissions to this action. So I'll be going to my settings, I'll be going to actions tab, and I'll be giving the right permissions to this workflow. or the action which we just now created. As of now, it just had read permissions. Now I have given that workflow write permissions also. So now we'll rerun this thing so that it is updated right now. So same thing, like yeah, same thing for the users. As of now, we are not checking users over here in this file, but if you want to use, if you want to add users also, you can add it in the configuration file, and this will ensure that only specific users are able to trigger this thing. So as of now, you can see that I triggered this job. I had a rerun button over there on the top in the GitHub repository. I did the rerun on my side, but suppose say I am not authorized to do that. So you can add that configuration also in your code QL file so that I don't see that button at all. Or even if I click on that button, it should show me failed. You don't have access. So something like that you have to do. And then in your security things, yeah, here, like in the code scanning alerts, you can see you can set it up also, which will already be done with this action if we see here. So once this is done, you will be seeing that whenever you push a code to this repository, I'll be quick here. Suppose say if I make a file test.js, I write some code over here and I just commit my changes, which is just pushing the code to this repository. Test.js is over there. If I go on actions tab, you can see what happened. Whenever I push anything, whenever I do any of the commit, it will trigger this workflow over here. That's what in configuration we write if you are following up. So on every push, on every pull request, this will trigger and this will perform those checks, everything. So it will be doing all the initializing code QL, auto build, perform code QL analysis, and it will post me the report also as well. So right now there won't be any alerts which you'll be seeing because I didn't write any code, right? It was a normal texting or a normal this thing which can be ignored also. But yeah, it will be performing this thing. Maybe I'll just pull out one code and we'll let it run in the background. Then at the end we'll see what output it gave. I'll just pick out a malicious code and let's see if our code QL is able to detect that or not. I'll be posting a code for cross script attack. If you are aware of that, if some cybersecurity people are there in the audience. So XSS attack, I'll be posting one code such that it's doing a XSS attack on the repository. Yeah. Right now, it gave me a green check mark, and if I go to my security tab here, here if I go on view alerts, you can see that nothing is there. Okay, zero open, zero close, because no, like there's no security vulnerability as of now. I have a XSS attack code right now. I'll be pasting it here and I'll be committing it here. Let's see if it's able to detect or not. So yeah, Shubham, yeah, you can ask if any question is there, like regarding CI/CD, so we can cover that before I move on to the next file risk.
Okay, so how GitHub Actions specifically improve security of the CI/CD pipeline and how they contribute to the security measures?
Okay, so in GitHub Actions, in GitHub Actions, we have environment isolation. Okay, so it provides isolated environment. So whatever, when we did this, like when I show you the demo, whatever process happening in the action, it is creating a separate environment for itself. It will not affect my repository at all. So when we run that, it will automatically create a branch of itself, which is not visible to you at all. So it will perform all of the actions whatever happens. If code is to be deleted, if something has to be done, all of that will happen in the isolated environment, so nothing will be affecting your repository at all. So running workflows, or you can say certain other things, would be done in its own environment, which will prevent any interference or anything in your repository. Second thing is secret management. So as we said about credentials and all that, that's a very good thing which you might have seen in GitHub settings, or many of you might be using also. It is secret management. So you can create tokens, you can create secrets in your GitHub repository, so that you don't have to hard code your credentials in the configuration files. So I'll show you one example in the repository of some popular company. They would be using secrets environment variable over there, and this is one of the concept which GitHub Actions provides you. So that's a built-in security secret management that allows you to store and access sensitive information, such as you can say API keys. So certain companies use APIs, certain external APIs. So you can post your API keys over there in the secrets, or you can also encrypt your secrets via hashing. So you don't have to write code for hashing separately. GitHub Actions, if you enable the hashing, this thing, it will not print the actual API key credentials in the logs itself. So that is one secure thing which GitHub Actions provides you. Permission and access controls. So as I said, permission and access controls are very much important. In GitHub Actions specifically, it's very easy for you to handle those things, because it will integrate everything from your GitHub account directly. You don't have to, what I can say, if I say about Hariket, it will take all the permissions from my account directly. It will not, you will not be required to write permissions for me separately. So whatever, like if I provide read permissions for my GitHub account, it will take read permissions only. I don't have to reconfigure my access over there. So this will ensure that only authorized users are able to configure the CI/CD process, pipelines, anything over there. Then fourth part is security scanning, which is one of the things which I did in my demo. So security scannings, as I showed you before, you have certain security scanning tools. You have Code QL, which is one of the things we right now configured for our repository. You have Dependabot, which is also you might be seeing in your React Node.js repositories, Dependabot alerts or something. These kind of alerts are all automatically integrated in your GitHub repository, so that it helps you identify and fix security vulnerabilities in your code and dependencies also. So specifically talking about Dependabot, it will tell you if you are using some deprecated versions of library or deprecated packages are there. It will suggest you to upgrade your package version to this thing, from the like from this to this. So it will be giving you alerts for that. Then CodeQL thing, which we integrated right now, it will give you risk like you are exposing data. You have a SQL query. If it's if it's prone to some injection attacks, then it will tell you to optimize that query. If you are exposing certain user data, suppose say you have a HTML form and you are collecting contact information from the user. So and when the user clicks on submit, you have a backend logic written for it. How are you actually executing, whether email should be triggered or whether this information should be added in database. So if you're exposing this message thing or the information which user is passing from the front end directly, then it will tell you also about such things. Like CodeQL will tell you that you are exposing user data directly to the public or something in your piece of code. Or suppose say you have as developers, I'm talking about me, we have a habit of writing console.log everywhere. So suppose say you're passing your code for review, you're actually finalizing your review and you are pushing it for the review. You forgot to erase console.log from certain files. So even CodeQL will tell you about such alerts also, that console.log is present over there or something. So you can fix those things. Fifth part is I can say GitHub Actions has automated security checks. So GitHub Actions allows you to automate security checks. So uh, there are certain things which are there, uh, which is complex for me to say, but yeah, in short word, it's told as vulnerability scanning, which is there in the settings as well. If you have an enterprise or a professional account in GitHub, you will be able to customize it. But as of now, if you have a free account, you can enable the vulnerability scanning part, and it will do the default scanning for you. Default checks would be performed. And then sixth part of GitHub Action is like customizable workflows. As I said, you can customize anything. Right now, as in my demo, I showed you that I only wrote my configuration. I myself wrote the configuration. I scheduled it on my time whenever I wanted. what all steps I wanted. Everything I configured it on my own will and customization. So that's possible in GitHub. Both options are there. As I saw on the right side, there were certain pre-made workflows, and on the left, you have the provision to customize your workflows. So those things are provided by GitHub Actions, and then community contribution. So what I mean by that, you can see in steps I used certain pre-made actions only. Like when I type the name, I type GitHub slash underscore this thing actions at the rate v3, which is a pre-made this thing action. So community contributions are like suppose say I am publishing my action to the internet. You can directly use it in your repository also. So it's not always that GitHub only has to pre-make action over there. Even some of your developer friends can also make packages of their own, the workflows of their own, and you can integrate in your repository. But there's one thing which you should take care, that you are taking it from a person who is reliable. Okay, when you are stepping out outside of GitHub, like when you are not taking pre-made workflows from GitHub but an outsider developer, make sure that he is actually like an ethical person or a proper person to take workflows from. Because if you are depending on my workflow, suppose say some of you from the audience are trying a workflow and you are importing the action from my workflow file, you should ensure that I am the right person, or like I am actually trustable or not. Because sometimes what will happen, suppose say I change my workflow file. I, instead of doing certain action, I post malicious thing in that workflow file. So every person who is importing actions from me or workflows from me would get would get impacted for sure. So that's one of the things that you should take care. But yeah, this is one of the feature I would say of GitHub Actions that is there. Like a lot of community contributions are there, so you don't have to hard code all the workflows. You don't have to customize all the workflows. You might find certain things posted on internet, or certain configurations already available on internet. You can directly import and use them. Then now moving forward with the risk part, like we have five more risk pending over there. So the sixth risk is insufficient credential hygiene. So if credentials for the application in the pipeline are not managed well, like if they're leaked in certain security management, then it will be very much, you can say, bad, like for the company. So credential hygiene in the sense that you can say API keys. Okay, so when I give an example of API keys, they may get expired after some 30 days or maybe 1 month or 2 months. You might have an expiration period. So it's your you can say your duty to actually update all of your secrets, all of your tokens with new values, so that old values are not used. Because sometimes you will be just saying that how will it impact my repository, because anyhow that token has expired. So even if I'm using that old token, what will happen? You will never know that, even that token can be used in certain ways to compromise or affect your repositories credentials by some outsider, or even the third party from where you are taking this API. So always just never, you can say, leave your credentials on the old thing. You can update those things, secret managements on your own. Then the seventh part is insecure system configuration. So there are certain flaws in your security settings as well. You should ensure that they are updated to all the, you can say, updates provided by your certain operating system. If it's Windows, just go to Windows Update and update all of the things and everything. And if not, then you can establish a process to periodically review all the system configurations. So uh, how do I explain this is, when I wrote in my demo, right now you would have seen, I wrote runs on Ubuntu latest. That's what the system configuration I am expecting over there. But if you have certain configuration like Ubuntu and you have written certain version over there, it should be your specific duty to update it, because there might be certain security flaws happening in that operating machine, in that specific Ubuntu version or that specific window machine. So you should take care that it's not that case. And yeah, one of the recommendations here would be like you can maintain an inventory of systems and versions in use. You can include a mapping of designated owner for each system. But all of those is, I would say, very difficult for you to do. Instead, you always go for the latest machine, latest in the sense one stable machine. So that will ensure that you don't have any security flaws. So you can update your CI/CD process according to that. Eighth risk is ungoverned usage of third-party services. So in CI/CD, you have lot of provisions for third-party services as well. In settings, as I said, you have to give permissions for it to read or write or whatever permissions you have to give. Just give it in a governed way or give it in a proper ethical way so that the third party does not gain full control on your this thing. Because if you don't do it, then such kind of impacts could be there, which I've listed, which is like insufficient implementation of RBAC, or you can say the third party can write the code, make changes on your code, or it might one of the common things which I can say here is third party will not be showing your website, but it will be showing their own publicized ads or something on your websites. So such things can happen. You don't want that third party to show ads on your website because it's your product, your application. So if you don't control the access of third party services, then it's very much again, it will be very fatal for your application, your product, whatever you are doing. So for a recommendation on this, how to avoid this is like you can review all the third party integrations and remove the ones which are no longer in use. It does not matter even if it has a read permission. If you're not using it, just directly remove it. Don't need to even give read permissions to that application. And one of the major procedure is you can add these services in artifact repository or something, so that like whenever the version changes, you have to gain an approval before using that specific environment, or that level of permission is taken from the artifact repository. So that is one of the recommendation over there. Then ninth part is improper artifact integrity validation. So this is one of the things which I was saying. So artifact repository is a good thing, like is configured, but how you are using it in your workflow files, that can be like one of the things that is you should take care of. You should not import your artifact repository. You should not hard code your artifact repository configuration. You should store it either in a secret, or you should connect it background, like in background. Like it should not be anywhere visible in your configuration file, because when you are importing your artifact repository, or when you are publicizing your artifact repository in certain configuration file, attacker will definitely see that thing, and attacker will definitely change that line of code so that he connects to his artifact repository, or you can say he'll just eliminate that process itself in between. Like you should not like he'll just make sure that either it's done from his repository or either it's not done at all. Like you're not checking any artifact repository validation at all. This should not happen. So if you know if like one of the recommendations for this is you can sign commits using a unique key for each contributor. So if you see in GitHub, you will see a verified tag on each commit, which is like it signs the commits with each hash value. But when you are making the same commits from your Git, your local machine, the commits are not signed with a hash key value properly. So you can ensure that commits are signed by each contributor, so that the can say the unauthorized user on a public user and hacker cannot actually change any of your configuration files just like that. You can additionally use tools for signing verification of code. There are certain tools apart from GitHub also. You can use those tools to verify or sign your code so that unverified softwares are not pushed to your pipeline or your artifact repositories. You can measure configuration drift, so you can potentially avoid these resources that are deployed by untrusted sources or processes. What does that mean is basically if you have a third party service and there's an untrusted process that it may want to execute to serve your action, you should not allow it to do. You should like in your configuration drift itself, you should just mention it that you can fail the process, but you don't want it to execute that untrusted process at all, because that will just lead to certain adversary which we don't know. Like as of now, even if I want to explain, you can never know what impact it can do on your repository. So just write the configuration in such a way that either these processes happen or nothing at all happens. Like you don't want any untrusted process to happen without your permission, or without it being present in the configuration file. Then the last and the final risk is insufficient logging and visibility. So this risk is basically like allowing an adversary to create malicious activity without being detected in any investigation. So he'll do certain things in the pipeline itself rather than the script part in the pipeline, in the sense, because as I said, pipeline is different from your coding. Pipeline will take the code and it will execute the processes, commands, everything. It will run in background. So in background you may never know what is happening, right? If somehow the hacker gets to know where this pipeline is running, in which environment, in which URL, in which remote server, he may try to attack the pipeline directly, so that he may stop the pipeline, or he may, you can say, add a step before the pipeline to proceed to success state. So you should not, like, you should allow that logging is there. Logging in the sense proper logs are entered in your system, so that you know if a hacker was introduced in the system, or if certain things were there, if he redirected your pipeline to some other step or something, you need to ensure this thing. And whenever an adversary happens, like whenever something which is not expected happens, you should trigger a certain mechanism, so that pipeline is stopped, that position is stopped then and there itself. Otherwise, even like I'm saying about logging, even if you have logging, but you don't have any specific measures to do, like suppose a hacker is coming, he's doing all the things, you have proper logs for that, but what will you do after he has actually done the attack on your repository? There's no specific point of that logs. Logs is only there for, like, monitoring or triggering the actions for your security. So not just logging, but you also have to check up the visibility of the actions. So ensure that there are certain security actions that are triggered as and soon when they, you can say, detect a breach in your this thing, breach in the pipeline or breach in the background processes. Recommendations for this is like you can identify all the systems in the organization, and for every instance you can implement this logging and actions for them. When I say instances, it's like, as I said, in organizations, you don't have one version of the application. You have multiple options. You can have one, you can say, main center in India, another can be in Asia, some other Asian country, some Japan, some other Paris. You can have multiple servers, right? So suppose say if Indian server goes down, you can directly reroute your clients to Paris server, so that your application is still running. I mean, your clients don't have to see this error message that application is down or something. So companies, when you step in corporate, you'll see that you have multiple servers where the same code is being run or the same application is being hosted. So same thing, like for a logging and visibility thing, ensure that all the instances, like not just Indian one, but all, even Paris, Japan, China, whatever instances you have, all of them should be having this logging and action part synchronized in all of the machines. Then second thing is you audit, or you ensure that all the auditing process is done properly. Shipping logs to centralized location. So that's what I was talking about. So when a certain risk is mentioned in the logs, you can ensure that it's triggering something. So simplest thing you can do is you can trigger a mail. So suppose if some hacker came and in your log it detected that a unidentified machine is trying to access. You can trigger a mail to your developers, all the developers in the in the team, so that they'll know that yeah, something like this has happened. So everyone can actually take some action on this thing. And apart from that, you have SIEM, which is mentioned over here, which is another complex thing of how you can trigger the actions. But simplest of the thing is you should trigger a mail. At least mail should be triggered to your manager, your developers, or your teammates, so that they'll know that such thing has happened. Then fourth part is like you can create alerts to detect anomalies. Alerts in the sense in the application also, when you're accessing, suppose your application URL, the domain, if something malicious is happening in the background, you can pop up a warning in your banner in your application, so, to users that stop using the website right now, because something is not right in the background, so that so that the users are safe from actually providing any sensitive information. Because if you don't show such alerts in the website, what will happen when the users are submitting any form with their personal data, that will be accessed, that will be sent to the hacker and not to your system or your database. So it's your duty to create alerts or create pop-ups, banners in your front end part for your application, so that if something malicious activity is done, something is down, not working, you can tell your users to stop using it right now, and you are working on this fix. So that's what you can do over there. And this is the part of the GitHub action. So yeah, how we can hack GitHub Actions, or how an hacker can hack GitHub Actions is here, specified over here. So all of these things which you see here can be hacked, or it is publicly available for the hacker to configure or change. So if you are using any of these things in your GitHub action, you should make sure that it's hashed, hidden, or you can manage it using GitHub secrets rather than publicly hard coding it. So you can see GitHub event issue title or GitHub event issue body. All of this is connected to your repository, your code part, and your artifact repository also. So you should try to make sure that all of these are not available in the configuration file. If you want to use it, you use it via some other, you can say other settings, like the settings present in the GitHub repository. You can configure these values over there and not directly use it in your configuration file. Because simplest of the thing, like suppose if I change this part, GitHub event.head commit author email. If I change the author email itself, it will not point, that commit will not point to your this thing. Like it will show me that some other person has made that commit. I'll not be able to track the history of who made these changes. So suppose say, how I can give an example is, suppose say I change this author email to my manager's email address. Okay. And now I, as an intern, I am pushing some malicious code to the repository. So what in GitHub it will show me? It will show me that my manager has made that commit, but in reality, I have pushed that code. So this should not happen over there. This head commit author email configuration should be taken by default from GitHub itself, and not hard coded way, in not a hard coded way, because this will pose so much of impact on your repository or organization, everyone. So just make sure that this list is reviewed before you write your configuration files. If anything of this is there, make sure that it's coming from secrets, or it's not present at all in the configuration file. You can use it from some third party thing, third party in the sense from outside, like from GitHub settings, not directly in the configuration file. So yeah, and these are some of the resource links which you can actually look forward, like after the session you can just see to it, and you can refer certain points from here also. And yeah, that's all from my side. Shubham, if you have additional questions, anything that is unanswered, you can ask.
No, thank you so much, Hariket.
Yeah,
The session was actually really informative.
yeah.
So, from audience, does anybody has any questions? So they can unmute or like post it in the chat box.
Yeah. In some code bases, like for example in Python, some packages are very heavy.
Yeah.
Can we rely on GitHub Actions to like compile uh, those? Because essentially it's running on some server
Mm.
now.
Yeah.
That's
So
my question. Like,
we have certain thing known as cache in this GitHub Actions also. So you can actually have a cache for this thing. So whenever you push your code, it does not have to build or you can say install all the packages, or like every time when you push that thing. If you have this cache thing over there, the package would already be present in the cache, and only the code part would be actually analyzed in the GitHub Action. So that is one thing which you can do. Only disadvantage of this is you have to manually you can say clean your cache periodically. Like suppose every month you have to clear your cache, so that the package is installed or updated after 1 month or something. So that is one fix which you can do. Other thing is actually, that's the only way as of now which I can think of, the cache part. Like if you enable a cache in your GitHub action, then you don't have to install that package every time, because it will be already present in the cache. Yeah.
All right, thank you, Harkit. It has come to my notice that you kind of ranked first for like VIT Chennai for your
Yeah,
congratulations to you on that.
thank you. Yeah,
So, like, it's a kind of like great achievement. And yeah, once again, thank you from behalf of Open Source,
yeah,
taking your time out for joining us today.
yeah,
And we were like truly honored to have you here. And thank you again.
yeah, yeah.
So, guys, we'll be ending the meeting. You can like kind of leave. Thank you so much for joining us today. And we'll come to you again with another episode of TechCast very soon.